Hello, this is Sachin. In this lecture video, I am going to explain the concepts of real-time operating system based embedded system design, Shibu KV introduction, KV's introduction to embedded system book, chapter number 10. This video is part 4 of the series of chapter 10. So in this video I am going to explain the task communication concept. So already in the previous 3 videos I have explained the above all topics. So in this video I am going to explain task communication 10.7. So what is task communication? So when in a multitasking systems, the process run concurrently, as you know. In a previous slide, I explained about this. Multiple tasks run on the CPU has to interact among themselves to exchange the data. For example, simple example I want to give. If you take an example of a mobile, so in a mobile you might be created few tasks, one task for keypad, another task for display, one more task for sensor, one more task maybe for memory. So the task which is created for keyboard, when somebody presses the key of the mobile, then at the same time the keyboard related program has to execute, for which identify which key is pressed, and at the same time the key which one is pressed, switch or a key which one is pressed in the keypad has to be displayed on the screen. And we have created the two separate tasks, one task for keypad, another task for display. Then the keyboard task has to communicate with the display task. So as you know, they are run at different time. You feel it is concurrent, parallelly running, but CPU cannot handle both the tasks to run on the CPU at the same time. That's why operating system allot the time slot to execute task for keyboard separately and task display separately. So when these two, the task has to intercommunicate for data exchange, because whatever the key we have pressed, it has to be displayed on the display. Right? So the key pad related program, when task is executed, task code is executed, it identifies a key and it will pass the message to the display for displaying that particular key which one is pressed on the display in it. For that we have to exchange the data between them, then the both task has to communicate. So when, as you know, these two tasks run at two different time, not at the same time on the CPU, then how to communicate? There are different modes of communication, ways of communication, that in the next slide I will cover those. So first we try to, the OS are classified as the cooperating processes OS. The cooperating interaction model, one process requires the input from another process to complete the execution. For example, this just I explained. To display the key which one is pressed, it has to need information to be passed from the keypad task. The communicating process do not share anything among themselves, but they share the system resources. So they are called the communicating process or tasks. Cooperation through sharing, the same thing. The exchange data through some shared resources. So how can the keypad program will share the information that this particular key is pressed to the display. So they have to share the data through shared resources, some common shared resources in between. They have to create, these processes have to create, so that they easily can intercommunicate. That's also inter-process communication. This is called as an inter-process communication, the communication between the two processes, keypad, example, the display. So cooperation through communication. No data is shared between the processes, but they communicate for exchanging the synchronization. In some of the processes execution, they need not to exchange any data, but for process synchronization, so first you execute, second I will execute, next third, fourth, like that, there should be some synchronization among the processes required. For that they exchange a single bit data, that is flags they share. Okay. The interprocess communication is IPC, what is called as an IPC, interprocess communication, adopted by OS kernel, are mainly classified into shared memory, message passing, and remote procedure call. And the shared memory has different implementations: global variable implementation, pipes, named and unnamed, memory mapped objects. So these are the three different structures we implement for inter-process communication among the shared memory. So message passing, the different structures are created for inter-process communication under the message passing. The message is passed: message queues, mail boxes, mail slot, and then signals. Remote procedure call. Last one is a remote procedure call. So we'll see one by one of all these. First, shared memory, global variables. As you know, the processes share the same area of memory to communicate among them. The information to be communicated by the processes is taken to the shared memory area. For example, I told you, right, process 1 and process 2. Time being assumed this process 1 is a keypad process, and the process 2 is a display process. So how the keypad will share that this particular button is pressed? So it keeps that information in the shared memory area, which is shared commonly by these two processes, process 1 or process 2. For example, process 1 is a keypad, and the process 2 is the display process or a task. So then when the process 1 is executes, whatever the data it has to share with the process 2, it will keep in this, store in this shared memory area. And then when the process 2 resumes its execution, it will collect the information from, receive the information from a shared memory area. Then one simple analogy example for the queue is here. A notice board in the college. And the notice board in the college authority will display the messages. And then it's a shared area where the one will display the message and the other students will access that. So this is one simple example what we can use to understand this. The IPC shared memory pipes. The shared memory pipe is one more structure where the process which create the process 1, which creates the pipe, is called as a pipe server, and the process which connects to this pipe is known as a pipe client. And then the pipe server will place the messages in that area memory, and then the pipe client, that is the process 2, will read the information from that. It can be unidirectional. Sometimes it may be bidirectional also. So unidirectional pipe allows the process to communicate, connecting at at an end of the pipe to write the pipe, and the processes which are connected at the other end of the pipe to read the data. Bidirectional pipes for the data exchange between the processes, like analogous to pipe. The processes which create the named pipe is known as a pipe server, and the processes which connect to the named pipe is called as a pipe client. A particular process name is mentioned so that the all will accept that message, but the only one, the client which is have that particular address or a name, that will accept, and rest all will discard the other end if it is more than one client is connected. Okay, this is called as a named pipes. So next one is a memory mapped objects. So shared memory technique is adopted by a certain real-time operating system for allocating the shared block of memory, which can be accessed by the multiple processes simultaneously. It's called as a memory mapped objects. Memory objects created and the physical store for the for its reserved and commented. The process can map the entire committed physical area or a block of it to its virtual address space. So this is how the shared process 1 and process 2, which is they are sharing the data through the virtual space. So this is how that is explained here. This is the committed physical area, and this is the virtual space where they are exchanging the data among themselves. Next, message piping, another technique. So in this message piping, synchronous information exchange mechanism for inter-process or thread communication we come across. Only limited amount of information is passed through the message piping, whereas in compared to the shared memory, the message passing is relatively fast and free from synchronization overheads compared to the shared memory. So here in this there are a few techniques are there. So one technique is message queue. The message queue is a structure or it's also kind of a shared memory. Memory is used to create this structure, message queue. A message queue is created as a first in first out message queue. So like a different algorithms you can adopt and create the one structure. The messages are sent and received through the send and receive methods. The messages are exchanged through the message queues. The one message process which want to pass the message to the process 2 will send the message to the message queue, and the other end, when the process 2 resumes the execution, and then at the time it will collect that. The next one is a mailbox. It's a special implementation of a message queue only. The one-way communication, where the one who want to communicate with the other tasks. For example, here in the diagram you can see here task 1 create the mailbox, and then it will pass the messages on that mailbox. This is also a memory structure only. The one task process create the mailbox, and the other task process is subscribed to this mailbox for getting the message notifications, and then they will read the data from that. This implementation of the mailbox is OS kernel dependent. It depends on OS to OS. Signal. So signal, when sometime it is not required that the more amount of large amount of data to be exchanged. Only one flag is enough. A yes, no, on off like that. So such notifications also can be exchanged between the two processes. That can be achieved by using the interrupt services as a signal, or other means are there to signal. Signal do not carry any data and are not queued anything. Signal is instantaneous instance, and that is passed from one process to another process in the form of interrupt service routine. A remote procedure call last in the message passing is called as a remote procedure call. So remote procedure call is a mechanism used by the processes for data exchange. The procedure of another process to, running on the same CPU or on the different CPU, which is interconnected in the network. So for example, the process 1 is in one PC, the process 2 is in another PC, or in PC in one college, and the another PC in a remote place where it is hundreds of kilometers away from the college number 1. The process 2 is in run on the another PC in the college number 2. So in such cases, these two processes communicate through the network, and the RPC is mainly used for distributing the applications like client and server applications. The one who creates this remote procedure call initiate this called as a server, and run the server application running on that, and then the other end, the process which is running, the process 2 on the other side, which receives the data is or information, is called as a client process. And CPU and process containing the procedures which need to be invoked remotely is known as a server, and the CPU process which initiates the RPC request that I told you, right? Process 2 will request for process 1 for initiate the remote procedure call for information interchange, is called as a client. And client and server are maybe at a different platform operating system, but the common RPC are designed or created for all kind of platforms. The RPC communication can be either synchronous or asynchronous. This one diagram will help you to understand the processes running on different CPU, where which are networked, connected through the network internet. And then the another one is the processes running on the same CPU. Okay, so remote procedure call, a socket is used in when it is communicated through the network. That's why the socket is the implementation communication in the remote procedure call when the processes are at too far away from each other. The socket is a logical endpoint in the two-way communication link between the two applications running on the network. Okay. So for this we use inet socket, are classified into a data stream socket and datagram sockets. Okay. So this will the end of this part, where I explained the inter-process communication techniques, and then in the next video I will cover the synchronization of processes. So please watch the video, and if you liked, press the like button and subscribe.